Hi, everybody. Welcome to my session. I'm going to be talking about AI powered infrastructure, specifically cloud TPUs, for the next 10 minutes. Cloud TPU. TPUs stand for Tensor Processing Unit. It's one of the fastest, most efficient, most sustainable ML systems in the world designed by our engineers at Google. Cloud TPU is one of the key differentiators, not just for GCPs, but for the entire Alphabet. And here is why. Many of Alphabet's key products include Search, YouTube, Translate, and Gmail, as well as state-of-the-art Google AI models such as Lambda, Palm, Gemini. They are all powered by TPUs. Externally, we are rapidly growing an ecosystem of ML practitioners who are actively utilizing TPUs to push the boundaries of AI in a very cost efficient and sustainable manner. Importantly, our customers can now enjoy a much better ease of use with the recently landed TPU VM architecture and ML frameworks of choice. The landscape of AI has dramatically shifted. Larger, more complex models have given rise to greater AI capabilities across a range of applications. But at the same time, larger models are also driving up the costs for AI computing astronomically. Today's state of the art LLMs are trained on tens of millions of dollars, have hundreds of billions of parameters, and need trillions of tokens of data to learn. At Google, we are no stranger to this phenomenon. Almost a decade ago, we realized that if users search their voice just for 3 minutes per day, Google would have to double its data center capacity to run speech recognition AI. It's with that realization that we built the first generation cloud TPU. Since then, we have rapidly advanced with every iteration. From purpose built AI chips to the highest bandwidth optical interconnects, to efficient but highly scalable liquid cooled data centers, TPUs have become powerful supercomputing platforms to meet the computational demands of the modern Gen AI workloads. Let's take a closer look. With the latest generation, which is our Cloud TPU V5E, it's the most cost efficient, versatile, and scalable cloud TPU to date. First is cost efficiency. Cloud TPU V5E provides 2 times higher perf per dollar when training large Gen AI models, up to 2.5 times higher performance when running inference on them. Second is versatility. In addition to running both training and inference, TPU V5E offers 8 different VM shapes to support the full breadth of LLM and Gen AI model sizes as large as 2 trillion parameters. The diverse VM shapes offer a wide range of computing horsepower and memory capacity, which allows you to choose the optimal shape to suit your AI models. And because it's a TPU, it's been designed to scale. Using our largest MultiSlice technology, you can easily scale your model training across tens of thousands of chips. Additionally, you can conveniently leverage the exact same out of the box XLA programming model to scale that you use today. For all of you technophiles out there, I know you're craving to see the details. TPU V5E is not the largest TPU we have seen, but it is in fact the most efficient TPU to date. In a world where we are confronted with a global AI chip shortage, we have changed the way to think about serving our customers. So we've chosen to make every chip count. Every TPU V5E chip packs a punch, delivering nearly 400 teraops of computing while scaling 1600 gigabits per second over a blazing fast interchip interconnect. Each pod features 256 chips, but it can be strung together across tens of thousands of chips using our Jupyter data center network. This elegant architecture allows us to offer V5E at an astonishing 54 cents per chip at the starting price. Starting today, TPU V5E supercomputers are available for GA in North America, with later availability coming to APAC and EMEA regions. To take the full advantage of TPU V5E platform, we have also invested in a complementary software stack. First off, V5E supports both training and inference on AI leading frameworks, PyTorch, TensorFlow, and JAX. You can train and serve models end-to-end on TPUs. Second, we are introducing 2 new scaling technologies. MultiSlice Training enables large-scale training of AI models over tens of thousands of chips. And multi-host inference allows you to serve models as large as 2 trillion parameters. Last but not the very least, Cloud TPUs are now integrated with GKE, enabling seamless workload orchestration. Furthermore, integration with Vertex AI will soon bring fully managed training and prediction workflows. So, this combination of elegant hardware and out of the box software provides a cost efficient and productive end to end AI development platform for you. Let's take a closer look at the inference stack. We start with the trained PyTorch JAX or TensorFlow model. We then export the model to a saved model using stable HLO. It's basically a portability layer between different AI frameworks and compilers. We run the saved model through the TPU inference converter, which performs initial optimizations such as quantization. We then compile this TPU compatible model using XLA, which does even more optimization, including high level fusion, GSPMD sharding for data and model parallelism, and low level scheduling. XLA also performs V5E hardware specific optimizations and compilation. So finally, you resulted with a V5E optimized model that can run on TensorFlow serving, Torch Serve, or SAX for JAX based models. As you can see, we are leveraging a robust software stack to take full advantage of the underlying powerful TPUs. We are also bringing high throughput and low latency inference to Cloud TPU V5E. When optimizing with our OpenXLA compiler, and the Cloud TPU V5E delivers 2.5 times higher throughput per dollar for a range of state-of-the-art LLM and GenAI models such as Llama 2, GPT-3, Stable Diffusion 2.1 as well. We can achieve this throughput performance without sacrificing latency. In fact, V5E achieves up to 1.7x speedup over the previous generation. So what does all of this mean? It means that you can bring your most accurate, most capable AI models to real-time production applications at a fraction of what you would otherwise have to pay. So LLMs and GenAI models continue to grow in size, and the computational cost, not just for training but also for serving, also grows hand in hand. Largest models require many chips to fit, and this is where flexibility of TPU V5E with fast interconnect up to 256 chip really shines. Cloud TPU V5E supports inference on a variety of model sizes. A single V5E chip can run models up to 13 billion parameters. And from there, you can imagine the scale. You can easily scale up to 256 chips and sometimes run models even with up to 2 trillion parameters and keep it still within the pod. This is a quote from Assembly AI, one of our customers. It's a testimonial from them for running their ASR models in production for their use cases. Well, we saw the performance for inference use cases and the versatility of VM shapes that we offer. Let's take a closer look at training use cases. With V5E, we're able to achieve 2x higher training perf per dollar compared to the previous generations. Across LLM 32 billion as well as GPT-3 175 billion parameters, we are also introducing AQT intake training. We are able to see step function increase in perf per dollar for training workloads. With MultiSlice technology, we are able to scale beyond power boundaries, achieving near linear scaling for tens of thousands of chips. In this specific use case, we are able to scale a single workload to 16,000 chips. With multi-slice training specifically, customers can achieve near linear scaling across pod boundaries to tens of thousands of chips with very few lines of code set up. It's a full stack solution across gang scheduling, orchestration, compiler, and runtime, as well as deep learning frameworks to achieve this breathtaking scale. Character AI is a specific customer that has given us feedback on multi-slice training. It's truly a game changer for them, and they are able to leverage true data center scale networking, and they've used JAX XLA to deliver out-of-the-box performance as well. We saw inference and training performance graphs so far, and here is an example of fine-tuning, and this is specifically for Falcon LLM. We are able to achieve 1.9 times higher fine-tuning performance from the previous generations of TPUs. Another great customer testimonial from Lightning AI, they were able to achieve 1.9x higher perf per dollar for fine-tuning, and again for a similar Falcon 7B LLM compared to the previous generation of TPUs. Again, Cloud TPU V5E is now available globally. We initially enabled access in Las Vegas and also in the East Coast. There are many more locations opening up in North Americas. Soon to will also be opening up in Netherlands and Singapore. This is our global availability zones for Cloud TPU V5E. We provide various consumption models to fit the needs of your business and use case. You can spin up a machine on demand when you need them, if you're able to. But if you have a bursting workload or are testing any new workloads, and on demand is a perfect way to go. Once you understand your steady state requirements, you can then purchase the committed use discounts. In this case, you're able to leverage up to 55% discounts across any region or a machine type family. If you need additional savings, then you can, of course, leverage spot VMs, which have the lowest price for your most tolerant workloads. Shared reservations will also leverage discounts for on demand and CUDs. Our customers are able to leverage a mix or a wide variety of these consumption model to achieve optimal price for their business needs. If you are interested, every customer will have a different path based on existing technology and business goals. Our public website on Cloud TPUs has all the information about the system specs, the scale, and the documentation for getting started as well. You can also contact your sales representative to get immediate access to Cloud TPUs and go from there. With that said, thank you so much for joining me today in my session. There are wonderful other sessions that are being put together for Women in ML Symposium. I hope you have a wonderful rest of the day. Thank you so much for making it.